Okay, everybody, so we're going to talk about my favorite F word today, friction. Friction is one of the forces that we have to deal with every day. We typically ignore it in physics a lot, but not on this unit. So by definition, friction is the force that opposes motion. It acts parallel to the surface. Think about sandpaper, think about ice. In some cases, friction is very helpful. With sandpaper, that's a good thing. We need it to help take down surfaces. And then when we have ice, it's slippery. It's not so good for us because it's hard to walk on. Not that we get a lot of ice. You could even just think of a really wet road on a slick surface, something with oil on it even. The amount of friction depends on what two substances are in contact with each other. Some things stick together more, some things don't. Some things have more friction, some things have less. So let's go through some of the forces that are going to be involved in these problems. So we're going to break the forces into net forces both in the x direction or the y direction, which is F net. In some cases we'll have x here, in some cases we'll have y. Fw is the weight, so we know that's mg. Frictional force is going to have to be something we calculate because the sum of the forces will add up to a certain thing and the friction will counterbalance it. So we'll use the problems. If I apply a force, we just subscript it with an A as applied. Then there's something called the normal force. For example, if you have something sitting on the table and it's not moving, well, it has weight pulling it down, but the table is holding it up. So we have to think of the normal force more like a supporting force. And finally, what manufacturers want to find out is what's called the coefficient of friction. Okay, they use the Greek letter mu. There's two kinds of friction. There's coefficient of kinetic, and there's the coefficient of static. Static friction is like a starting. Think about if you put a little kid in a wagon. It's a lot harder to start pulling them than it is once you get them going. And then this is a moving. So just about everything that you would push or pull, starting it is always harder than maintaining it. So there's two kinds of friction. We're just going to just find the coefficient in general. We have to also think about when do we have net forces when things are zero. Well, in order for net force to be zero, that means F net equals ma. It means that the a equals zero. And there's two ways that an object can have zero acceleration. First is being at rest. The second is if it is simply not accelerating, meaning it's at constant speed. So we're going to look for constant speed in our examples. Okay, so the first example that we're going to do is this one, and I'm going to work it through. You're going to need your calculator. I'm going to label everything as we go. So I have a 25 kilogram object moving at constant speed. That's huge right away. Okay, and just so you know, this first set of notes, we're only going to deal with pulling things exactly horizontal on the surface. We'll add angles a little later. And we're going to pull across a rug, and we're going to use 50 newtons. So the picture is important. This is the force applied, and it's in the x direction. The force that opposes motion and acts parallel to the surface is friction. So that would be on this arrow. This would be the weight, represent the weight. And this is your normal force. It would be the force of the surface pushing up. Okay, so you have a list. I'm going to go through this list and you're going to add in answers and notes at the same time. So first of all, we're going to look at things horizontally and then vertically. All right, in the horizontal situation, is it accelerating? No. It's at constant speed. What about in the vertical? Is this thing going to lift off the table and move up? No. So both of the accelerations, both horizontally, squared, and vertically, are going to be zero. This is typically almost always going to be zero unless we lift something off the ground. And then mass, I just put it in both columns because it's not going to change. But it's 25 kilograms. And be wary when I give you a quiz because sometimes I'll say, oh, a kid is in a wagon. You have to add them together. So make sure you have the whole mass. All right, so the FAX is literally what the person is pulling with. That was 50 newtons, so 50 newtons. So those are all pretty much considered given. It's also looking at what else do we pull with. So in this picture, you're only pulling horizontally. That's what, this is a horizontal applied force. Am I applying a force vertically? Remember, every time we use a Y, it's vertical. I'm not. The table is, but I'm not. So this is 0 Newton. So if I'm not lifting it up at some angle, this will always be 0. So these tend to always be 0. Okay, so let's do some things we have some formulas for. FW we know is mg. So in this case, it's 25 times negative 9.8, and it's down, so it's going to get a negative. Multiply those out, you're going to get negative 245 newtons. Okay. If I keep going down here, Fy net, so I'm going to go down here. Mu is at the bottom, and I just put it in one side. The normal force has a little bit to do with Fy net. So I'm actually going to do Fy net first. Fy net is mass times the acceleration vertically. So these two, it's 25 times 0, which is simply 0 newtons. There's another thing that we have to know about the net force. The net force is also equal to the sum of the vertical forces, which means in this particular case, Fy net equals Fw plus F normal. Because if I go back, sorry, I'm sliding down. If I go to my picture, there's only 2 vertical forces involved here. And this is how we're going to find the normal force. So 0 equals negative 245 plus F normal. Well, what plus negative 245 equals 0? Positive. So it's going to be 245, and that's going to go here. If I'm not pulling at an angle, and I'm just pulling something horizontal, these two numbers, this and the weight, will generally be the same value. One will be positive, one will be negative. That's how I found the normal force. All right, coming back to the x side. I'm going to skip to Fx net because that is m times a. Well, in the horizontal, it's the same thing. I'm not accelerating, so it's simply 25 times 0, which is also 0. In the same reason that this is the sum of the vertical forces, this is also the sum of horizontal forces. So what's in the picture that's horizontal? Fax and Ff. So those two have to add together. So in this case, Fx net equals Fax plus Ff. So 0 equals 50 plus Ff. This is how we find the friction force. And obviously 50 plus negative 50. Now, the reason that our friction force is negative in our picture is because the friction is directed to the left. We're still dealing with vectors. All these forces are vectors, up, down, right, left. And since we're at constant speed and nothing's lifting off the table, all of the net forces are 0, so everything is balanced. And so that negative sign doesn't mean a tremendous amount, except that we're going to the left. All right, so now we have to figure out mu. Mu is the friction force over the normal force. So, sorry it's a little squishy here. You're just going to divide negative 50 from friction over the normal of 245. And we're generally going to go to 2 units, or 2 decimals. And remember, this is newtons over newtons. And so just like anything in algebra, the letters are they're going to cancel. So negative 50, I have to turn on. Negative 50 divided by 245 is 0.20. So negative 0.20. And there is no unit on this. It's the only time you can put a unit on and get in trouble. Okay, this is the case of pulling something horizontally at constant speed. That generally doesn't happen first, that usually happens after. It's an easier problem to do. Like if you're gonna pull a wagon and you're gonna pull it horizontal, you're gonna accelerate it first, and then you'll pull it straight. So this would be more of the example. This would be considered technically, if I was to put it, this would be a kinetic friction because it's already moving. All right, so we're gonna go to the next example. This is a little bit different. This is what you would actually do first if you were actually pulling something. I have a 10 kilogram mass and it's accelerated at a rate. So you see that squared, that's an acceleration with a force of 45 newtons. All right, so if you look at the pictures, this is your FAX. You're pulling horizontally. Friction opposes it. And basically what happens when you're accelerating is you pull harder than friction, and that gives you a net force. So we actually have something that's not going to be zero. And then the table pushing up is the normal force, the object pushing down is the weight. So those have not changed. So those are the forces. So the mass is just 10. Okay, so 10 kilograms. It doesn't matter dealing vertical or horizontal, they're going to be the same. This has an acceleration now of 3.5 meters per second squared. But in this case, again, vertically, we're not lifting it off the table, so the acceleration is 0. Honestly, none of the ones we're going to do are going to lift off the table. All right, so let's work this through. FAX was given as 45 newtons. FAY, am I pulling it up? No, it is 0 newtons. So there's nothing pulling up. The table and the weight are doing their own thing. So I'm going to do the same kind of thing. I'm going to jump down to, well, I'm not going to jump down. I'm going to do the weight. So this is 10 times negative 9.8. You can do that in your head, negative 98 newtons. So I'm going to go to both of these. Fy net is m times a. Well, vertically, we get 0 newtons. Don't forget your newtons. Horizontally, we do have something. We have 10 times 3.5. That's going to be 35 newtons. And we're going to use that same formula, even though they both have an MA. This is the sum of vertical forces. We're going to keep pushing this because we have to use this. The same thing over here. This is also equal to the sum of horizontal forces. Okay, so in this case, Fy net equals F normal plus Fw. I don't care what order you put them in, it doesn't matter. So 0 equals F normal plus negative 98 newtons. So that means F normal has to be 98 newtons. So I'm going to put it up here. The Y ones tend to be a little easier. Okay, so in this case, it's the same thing. So now 35 equals FAX plus FF. Well, FAX was 45, so 35 equals 45 plus FF. That means FF has to be negative 10. Right? Negative 10 plus 45 would make 35. Now, technically, this would be static friction. I don't always make a big difference. It's just a technicality because accelerating means you started it. And it's always the friction force over the normal force. So I'm going to have negative 10 over 98. So if I type that in, a little glare there, we'll do there. Negative 10 divided by 98 is going to be negative 0.10. And remember, there is no unit on that. So this is our first part of friction notes. There's going to be a second part later with angles, but then before that, you're going to be using this in a virtual lab. All right, everybody, thanks. Bye.